Well, in this last video of this section, we're going to do basically a textbook type of a question, maybe a homework type of a question. It says draw a square, wxyz, which we have here, with sides of length 2 radical 5. So every side is length 2 radical 5, all 4 of the sides. Okay, well, I'm just going to indicate that on one of them, but we know all 4 equal side lengths are 2.2 radical 5. Okay, so label the midpoints of xy and yz. First we'll do xy as x prime. So I'm going to put x prime right there as the midpoint. It's the halfway point from here to here. And then the midpoint of yz is going to be y prime. Yz, we'll put y prime right there. Okay, next, draw line segment W, x prime. So that's going to look like this. I'm not using a straight edge, but I will bring a better picture in a minute where I did use a straight edge. Draw W, y prime. Okay, and then x, y prime. All right, almost done drawing all the line segments. Might have one more, let's see. For the point U, and we're defining U to be the intersection of 2 line segments. Remember the 2 line segments that cross, they intersect at one single point. We're going to call it U. XY prime, this line segment, intersects with WX prime right at this point. And that point we are going to call U. All right, so what is being asked here? We've got all the pictures. Find the length of each side of the triangle WUY prime. So basically we're looking for this triangle, looking for the dimensions of all 3 of those sides. Okay, well, let me bring in a slightly better picture where I used a straight edge for most of it. I've got a little additional information on this, but I labeled some of the angles 1, 2, 3, and so on. And I'm going to show that this is these are right angles right here. And obviously, if we have 2 midpoints, and the length of the entire side is 2 radical 5, then a length from one corner point to the midpoint would be half of that. It would just be radical 5. So let's see. First, I'm just going to make a note here. I'm going to start up here so I don't run out of room. I'm going to say x prime and y prime midpoints of their respective sides of the square. That tells us that, for example, and among others, triangle WXX prime, WXX prime is congruent to triangle XYY prime. XYY prime. And there are several justifications for that. I'll go ahead and say by SAS. And in fact, if you do, because the first side is 2 radical 5, it's the length of the square. That's the first side of one of them. That's the first side of the other. And then you're going half the length. Well, then you have a 90-degree angle, I should say. You got a side length, 90-degree, half side length. And the other one is side length, half side length, with the 90 degrees in the middle. And it should be obvious that those 2 triangles are also congruent to this triangle for the same reason. Okay, now, actually, maybe I'll start off by just doing one thing. On this triangle that I'm looking at, we want the measures of the three side lengths. One of them is very easy. One of them we can do right now, this one. Why is that? Well, notice that it's also the hypotenuse of this triangle, 90-degree triangle. So a squared plus b squared equals c squared. And what would that give us? I'm going to do this in my head here. What is radical 5 squared? Well, 5. What is 2 radical 5 squared? Well, it'd be 2 squared times radical 5 squared. 4 times 5 is 20. And that's going to be the hypotenuse squared. Well, 25 equals c squared means that c is going to be radical 25, which is 5. Okay, so we are 1/3 of the way done with this problem. We've got the length of the hypotenuse. Now we need the lengths of these two sides. Okay, so notice a couple of things. I labeled a few angles in here. And we know that the measure of angle 1 is equal to the measure of angle 2. Why do we know that? Because we've got two congruent triangles. Here's one, here's the other. Okay, and angle 1 corresponds with angle 2. So I'll go ahead and say corresponding parts of congruent figures are congruent. So now I want to figure out what the measure of angle 1 plus the measure of angle 3 is. And this is not going to be too hard to figure out. The measure of angle 1 plus the measure of angle 3, well, it's not going to be hard because it's equal to the measure of angle 2 plus the measure of angle 3. Because the step above, measure of angle 1 and measure of angle 2 are equal to each other. But what is the measure of angle 3 plus the measure of angle 2? That's a right angle. This is a square we're talking about. That's 90 degrees. Okay? Therefore, if the measure of angle 1 and the measure of angle 3 are 90 degrees, what's the measure of the third angle of that triangle? Well, 90 degrees. And I've already indicated it here. These two lines, let me put, that implies that WX prime, this line segment, is orthogonal or perpendicular to XY prime. All right, so this is going to help us out a lot. We've got 90-degree angles right here. All right, so what does that tell us? We know that, let's see, if I wanted to, we've got this. Okay, so if I wanted to, I could call that angle 4. And what would we know about the measure of angle 4? Well, it's equal to the measure of angle 3. The measure of angle 4 is equal to the measure of angle 3. And let's see, why exactly is that? We have a right triangle right here. We have a 90-degree angle, just like this triangle does. It has a 90-degree angle. So they both have a 90-degree angle, and they also both have another angle, 1 and 2, that correspond to each other. So therefore, because of this, we have two triangles that are similar to each other. That implies triangle WXX prime, WXX x prime, that triangle, wx, let's see, triangle, wxx prime is similar to, not congruent, triangle xux prime, triangle xux prime. That is by angle similarity. I'll put a note here, AA similarity. Any two triangles that have two corresponding angles congruent means the third one is also congruent, and they are similar triangles. So if I were to draw a picture of those two triangles, I'm going to draw wxx prime. I may be drawing it slightly different, kind of a different perspective. I'm going to put w at the top, x there, and x prime. And that is similar to the smaller triangle. I didn't make them look very similar, but they are similar. X, U, X prime. And they correspond in the correct way. W goes with X goes with U, and X prime goes with X prime. And these are right angles. So we can use the Pythagorean theorem on them. And here's what we need to do. We know that, let's see, we know that, let's see, what lengths do we know? We know this is a length of 5 right here. And we know that on the smaller one, we have, what is the length of the hypotenuse of xux prime? xux prime. What's this length of the hypotenuse? It is half the side length of the square. That's radical 5. Okay, so now let's see what we can get. Feel like we are almost there. Yeah, I think we are. wxx prime. This is, let's see, how can I get from wx x prime? Oh, I know more than that. Let's see. wx x prime has wx x prime. It has a hypotenuse of 2 radical 5. Not 5. Oh, no. My bad. 2 radical 5. And x prime is radical 5. We know all the dimensions. If we use the, let's see, wxx prime. So now I know that this squared plus this squared gives me 2 radical 5. wx x prime. 2 radical 5, radical 5, and then we have the hypotenuse, which is, why is that not working out? xx prime, wx is 2 radical 5, and this is 5. Yeah, we know what wx x prime is. That triangle we know completely. It's similar to this smaller triangle, xu x prime. So it's similar, so we'll have some kind of a scaling factor, and we'll be able to get these two sides. So how do you get the scaling factor? Well, the hypotenuse of this one is length 5. The hypotenuse of this one, which corresponds, the two hypotenuses correspond. How do you get from 5 to radical 5? Well, if you have 5, 5 is equal to, let me just do the division. 5 divided by radical 5 is radical 5 over radical 5. Because 5 is just radical 5 squared. That cancels. So the ratio, the proportion, constant proportionality is radical 5. So all I have to do is take each one of these sides, divide all three of them by radical 5, and we'll have the dimensions, the side lengths of this triangle. So once again, 5 over radical 5 is radical 5. 2 radical 5 over radical 5 is just 2. Radical 5 over radical 5 is just 1. So we now know the dimensions of this triangle, x, u, x prime. This side is 1, from there to there. This side is length 2, and that's radical 5. All right, that tells us the dimensions here. Remember that when you take the distance from a corner point to a midpoint of an opposite side, it's length 5. The distance from here to here is 5. From W to x prime is 5. That means if this distance is 1, what's this distance? It's going to be 4. 4 plus 1 is 5. And this distance from a corner of the square, or vertex if you prefer, to the midpoint of an opposite side, we know that's a 5. And if this distance is 2, the remaining distance is going to be 3. So, it was a little bit messy, but we found the dimensions of this triangle. The side lengths are 3, 4, and 5. Okay, now let's go to part B. Part B, I've already done some of the work for us in our diagram. It says draw a large square. I drew just like the other square. And notice the one we found the dimensions of. I've got it highlighted in yellow here. It says from the midpoint of each side of the square, so the midpoints would be here, 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 and here. Draw a segment to each of the endpoints of the opposite side of the square. So you can see what I did. Here's a midpoint right here. I connected it to the endpoints of the side opposite it. Down here, I went from the midpoint up to that corner, and then from this one, I went to that corner and to that corner, and on this midpoint, I went to that corner and that corner. Well, this is just kind of a fun counting problem. Okay, so I've done all of that. It says when you do that, it creates several triangles that are similar to the triangle from part A. This one, highlighted in yellow. Again, so here's one. It's obviously similar because it's congruent to it. That's exactly the same triangle. All right, how many of these can we find? Well, let's start drawing them, and there's probably more than you think there will be. Notice that if we think of this as the base of the triangle, which we would if normally I would draw the base at the bottom, notice that this line is parallel to it. What does that tell us about this triangle? It means it's a similar triangle. We have this angle, the same as this angle. This angle is used in both of those triangles. And since those two lines are parallel, this angle is the same as this angle. So now we have two triangles, I should say, that are similar. Well, we can do almost the same thing again with this triangle. I'll fill it in completely for this one. because this line is parallel to this line segments. So if you think of this as the base of the triangle, well, this line is parallel to it and it's hitting the other two sides. So since they're parallel, we get our third similar triangle. We got the yellow one, we got this one, and we've got this. So we found 3. Well, if I were to flip it over, so to speak, we have 3 more that are like mirror images. We would go, let me see, maybe I'll use the highlighter again. I should have a different color. Here, here, here. Kind of like a mirror image. Instead of having the right angle here, we have a right angle here, here. So we'd have this, the mirror image of this triangle is this triangle. The mirror image of this triangle is going to be this triangle. So now we have found 6, looking at it just from this perspective, kind of starting at this point. Well, if we were to go this way, we could do the same thing, and we would get 6 more, and here we would get 6 more, and here we would get 6 more. So how many can you find? I don't think you can find any more than that. So it would be a total of 6 times 4, which is 24.